Hello everyone. Today we are starting a new chapter, that is projection of solids. A solid will represent three dimensions of any object. It will have length, breadth and height. Under that we start with projection of a square pyramid. The square pyramid will be like this, with A B C D as the base edges. E is the apex. EA, EB, EC and ED will represent slant edges. Totally, it will have 8 edges. Now, we start the square pyramid from the top view. Now, as you are aware, this problem has been done to a scale of 1:2, so that this 80 will become, actually, when you write it, it will be 40 mm. This has been done to a scale of 1:2. Now, I have written the top view ABCD, which are the base edges, and I have written OA, OB, OC and OD. They are the slant edges, totally amounting to 8 edges. Now the corresponding front view will be in this way. Now once you write the corresponding front view, this point will become B dash A dash, because when you are looking from here, B is seen, A is not seen, B dash A dash. When you are looking from here, C is the nearer corner, D is away corner, C dash bracket D dash, and O dash will be the apex. Now if you count the number of edges again, here since it is the base, here you have 4 edges, and here there are 2 slant edges which are merging. One is OC and one is OD. As a result, there are 2 edges here. In a similar way, even here there are 2 slant edges, OB and OA, which are merging one behind the other, amounting 2 edges. Totally 4 plus 2 plus 2, 6, 8 edges, and you have an axis also. We have written axis also. Okay. Now in the top view also you have 8 edges. In the front view also 8 edges. And axis is not an edge. It represents axis of symmetry. Now this solid is rotated in such a way that it is resting on one of its base edges CD, that is C dash D dash, such that the base is inclined at 60 degrees to HP. Our axis is inclined at 30 degrees to HP. In this position, you are expected to write one top view. As you see here, when you are looking from here, how it is seen in the top view here, that has to be written. For that, we have a procedure, and I'll tell you in the form of 3 steps. Step number 1 is, first get all the points from the other view. See here, you get all the points, you draw the projectors, get all the points from the other view. As you see here, on this line you should get AB, on this you should get CD, on this you should get O. In that way, get all the points of the square pyramid in the top view. Now, the step 1 stays, once you get the points, join the outer boundary of these points. Once you join the outer boundary of these points, the step 1 will be completed. Now the step 2 will be, when you are looking from here, see whether apex is nearer or base is nearer. Now when you are looking from here, it is clear from the above, apex is nearer than the base. Since apex is nearer than the base, complete base cannot be seen. Also, when you are looking from the top, when you are looking from here, CD is the edge on which it is resting, and obviously CD cannot be seen. We will make it as a procedure. That is, if apex is nearer than the base, remaining edges of the base cannot be seen. In that way, remaining edges of the base means it is only CD which is remaining, that you make it dot dotted. That means CD is the invisible edge. That means now, after the end of second step, compare the number of edges what you have completed. Completed. Compute the number of edges what you have done. Totally, as you see here, we have completed 4 edges here. plus OD and OC. Totally we have completed 6 edges. Now we are left with 2 more edges. One is OA, one is OB. Now when you are looking from here, when the observer is looking from here, OB and OA are nearer edges to him. As a result, obviously, he can see those 2 edges. That is why I'll darken OA and OB because they are seen by the observer. And finally, I'll take the axis here and I'll complete the axis. Now, this is the second stage top view we call it. As you are aware, this first stage top view, first stage front view will be same as second stage front view because it is tilted parallel to VP. This front view and this front view are the same. Now, this second stage top view, if you see here, I have tilted in this way such that the edge on HP, that is CD, is inclined at 60 degrees to VP. Since the inclination to HP is constant and moved and rotated, the top view remains same. That means second stage top view will be same as third stage top view. That is why in solid edge the procedure is we move and copy, and then we'll rotate with respect to CD such that it is 60 degrees to VP. Now the problem is a square pyramid of sides 80 and height 150 has been resting on one of its base edges on HP with axis with base inclined at 60 degrees to HP, and the edge on which it is resting is inclined at 60 degrees to VP. This is the problem. And now we have to write the final stage in this position. How exactly it appears in the front view has to be drawn. Now you know very well the step number 1 is first get all the points in the front view. That means get all the points from the front view, taking the projectors from first, second stage front view and the third stage top view. Get all the points O dash, A dash, B dash, D dash and C dash. The step number 1 says join the outer boundary of these points. Join the outer boundary of these points. Step number 1 is completed. Now as you are aware, if you are looking here, step number 2 says compare apex with the base. Now when you are looking from here, base is nearer than the apex. Now when base is nearer, complete base can be seen by the observer. That is why we darken the base. A dash, B dash and B dash, C dash will darken. Now at the end of second step, immediately count the number of edges. 4 plus 2, 6 edges are already over. You have to complete 2 more edges which are OB and OD. Now if you want to see whether OB has to be darkened or made invisible and all that, you see the third step. Third step says all near edges can be darkened in the view, all far away edges are made dark dotted. Now if you see O dash B dash, you can see from the top view OB is the nearest edge, that means B is the nearest corner, OB is the nearest edge, hence OB can be darkened in the view. And OD, as you see in the top view, OD, when for an observer who is looking from the front direction, OD is the back edge and it cannot be seen. That's why we darken O dash B dash and make O dash D dash invisible. That is what we do here. Now if you see here, you have 4 base edges and I have all the 4 slant edges. In that only O dash D dash is invisible. And finally show the axis and complete this. This is the problem. The problem now says a square prism of sides 80 and 150 has one of its base edges on HP with axis inclined with base inclined at 60 degrees to HP, and the edge on which it is resting, that is CD, is inclined at 60 degrees to VP. For this position, when it is in this complex position, we have drawn the front view and the top view, and the front view looks this way and the top view looks this way. Since we have changed the position, since we have taken up 3 positions one after the other, finally this is called change of position method itself. Okay, now we go to the second problem. In this way we start in the same way, that is square pyramid. We start in the same way, top view, front view written. You have 8 edges here, 8 edges here, and now we are completely tilted it such that it is resting on one of its triangular surfaces on HP. That means it is resting on triangular surface O dash, C dash, D dash on HP. Okay. Now the procedure is, when it is tilted in this way, when you are looking from here, how the top view looks. For that, what you do, take all the points from the other view and see here, on this you should get C and D, on this you should get AB and get the point O also. Now the step 1 says, complete the outer boundary. Outer boundary you complete. When you are looking in the, now step 1 is over. Step 2 says, compare apex with the base. If base is nearer, darken the base. If base is not seen, make the remaining edges dark dotted. But in this case, base is clearly exposed. Base is nearer than the apex. For an observer who is looking from here, base can be seen. As a result, we darken the base also. Now, as you see here, totally, I have already completed 4 plus 2, 6 edges. 6 edges. Totally 8 edges have to be completed. In that way, what you do is, when you are looking from the top, the faraway edges are OC and OD. Obviously, the person who is looking from here cannot see OC and OD. Hence, we make OC and OD dot dotted, invisible. And take the axis, complete the axis. Now, what exactly we do here is, in the third step, the top view of the axis is inclined at 45 degrees to VP. That means, since since it is resting on the triangular surface on HP, the second stage top view and the third stage top view will remain same. That is why we take the same second stage top view, that is move and copy and rotate it such that the axis is inclined at 45 degrees to VP. Okay. Now the procedure remains same. We want the final stage front view. In this position, how it is seen in the front view has to be written. For that, take all the points from the other view. As you see here on this is O dash, and from here you get C dash here, D dash here, AB should be on this, A dash is here, and B dash is here. Step number 1, complete the outer boundary. Once you complete the outer boundary, as you are aware, here itself it is a triangular surface on HP. Here itself it is 3 edges, 4, 5 and 6 edges are already completed. 3, 4, 5 and 6 edges are already completed. Now you have to complete the remaining edges, sir. Okay. Now, as you are aware, in this, if you observe, as in the second step, you compare apex with the base. Now, in this case, it is clear that base is nearer to the observer than the apex. Immediately, in the second step, since base is nearer, we'll darken the base. Now you again count the number of edges. It is 3 here, 4, 5, 6 and 7. 7 edges are already completed. You are remaining with only one edge, that is O dash A dash. O dash A dash, if you see, AO is a back edge. For an observer who is looking from the front direction here, the back edge cannot be seen. As a result, he makes O dash A dash dot dotted, that is invisible, and finally show the axis. This completes the second problem. That is, the problem says a square pyramid of sides 80 and height 150 is resting on one of its triangular surfaces on HP with top view of the axis inclined at 45 degrees to VP. In this position, we are expected to write one top view and front view, and this is the top view and this is the front view.